Did you know how the red planet Mars came into existence? Around 4.6 billion years ago, the stage was set for a cosmic performance. In the grand theater of the universe, dust and gas began to swirl, their waltz guided by the invisible hand of gravity. This celestial dance gave birth to the planets of our solar system, one of which was Mars. This fledgling planet was not the red world we know today. It was a molten mass, a fiery ball in the cold expanse of space. Over time, the planet cooled and underwent a process known as differentiation. This process, like a cosmic sculptor, formed the crust, mantle, and core of Mars, creating distinct layers within the planet. This was the birth of Mars, a silent spectacle witnessed only by the vastness of the cosmos. So, the red planet was born, a rocky world, bathed in the light of a young sun. Can you imagine a time when Mars could have supported life? Quite a thought to ponder, isn't it? Early Mars, it appears, was a vastly different place than the Mars we know today. This was a time when Mars was warmer and wetter, a stark contrast to the frigid, dry desert that now dominates the Martian landscape. Indeed, the planet we see today, with its rusty red soil and thin, unbreathable atmosphere, is but a shadow of its former self. The evidence of Mars's watery past is etched into the planet's surface. Ancient river valleys crisscross the terrain, their winding paths a testament to the flowing water that once carved them. And where there were rivers, there were also lakes. These bodies of water, some the size of small seas, dotted the Martian landscape, providing a potential habitat for life to thrive. Now, when we talk about life on Mars, we're not necessarily talking about little green men or towering Martian warriors. No, the life we're discussing is much simpler, yet no less remarkable. We're talking about microbial life, the tiny single-celled organisms that form the foundation of all life as we know it. Some of the strongest evidence for this early Martian life comes from meteorites. These chunks of rock, blasted off the Martian surface by cosmic impacts, occasionally find their way to Earth. And within these meteorites, scientists have found tantalizing hints of possible microbial life. But the search for life on Mars doesn't end with meteorites. Scientists are also on the hunt for fossils, the preserved remains of Martian microbes. While no definitive fossils have been found yet, the search continues, with rovers like Perseverance and Curiosity scouring the Martian surface for signs of ancient life. As it turns out, Mars might not have always been the barren red desert we see today. The evidence points to a time when Mars was a world of rivers and lakes, a world where life, however simple, might have thrived. And who knows? Perhaps one day, we might find definitive proof that we are not alone in the universe. What about Mars as we see it today? Mars, the fourth planet from the Sun, is often referred to as the red planet due to its reddish appearance, a result of iron oxide or rust on its surface. But there's more to Mars than its rusty facade. Its current state presents a world of extreme conditions and remarkable features that make it a fascinating subject for scientific exploration. The Martian atmosphere is thin, composed mostly of carbon dioxide with traces of nitrogen and argon. This thin atmosphere allows for more sunlight to reach the planet's surface, but also results in a much colder climate compared to Earth. Average temperatures on Mars hover around a brisk -80 degrees Fahrenheit, although they can fluctuate dramatically. And let's not forget about the Martian weather. Mars is infamous for its global dust storms, which can blanket the entire planet for months. These storms are so intense that they've been known to block out sunlight completely, plunging the planet into darkness. Now imagine standing on the icy poles of Mars. Yes, Mars has polar ice caps made up of water and carbon dioxide, much like Earth's poles. These icy poles are a stark reminder of the planet's cold and harsh climate. Mars also boasts some of the most extraordinary geological features in our solar system. Take Olympus Mons, for instance. It's the largest volcano and the tallest planetary mountain in the solar system, standing 3 times the height of Mount Everest. Then there's Valles Marineris, a canyon that runs over 2,500 miles long, 10 times the length of the Grand Canyon. Currently, Mars is being explored by numerous rovers and landers from space agencies around the world. These robotic explorers are sending back invaluable data, helping us understand the red planet better, and getting us one step closer to potentially setting foot on Mars one day. Mars today is a world of wonder and extreme conditions, a testament to the power of nature and the quest for knowledge. Have you ever dreamed of a future where humans live on Mars? Quite the thought, isn't it? Let's delve into this fascinating possibility. The idea of humans inhabiting Mars isn't new. We've been imagining it in science fiction for over a century. But today, it's more than just a dream. It's a goal and a challenge that scientists and engineers across the globe are working to make a reality. But let's be clear, Mars isn't exactly a hospitable place. It's a world with intense radiation, a thin atmosphere and low gravity, about a third of Earth's. Not to mention it's bone dry, with liquid water almost non-existent on its surface. These conditions pose significant challenges to human survival and health. However, every problem has a solution. For instance, the radiation issue could be mitigated by building habitats underground or using local materials to shield living quarters. As for the gravity, we're still figuring that one out. Some researchers are looking at the potential of artificial gravity. Water, that vital ingredient for life, is another challenge, but Mars has vast reserves of ice, especially at its poles. Future Martians might extract water from this ice for drinking, growing food, and even producing fuel. Speaking of food, we might not need to pack all our meals for the journey. Experiments on the International Space Station have shown that it's possible to grow plants in space. Mars's soil, with a little help, could potentially be used to cultivate crops, making Mars a self-sustaining colony. NASA and SpaceX, among others, have ambitious plans to send humans to Mars. NASA's Artemis program aims to return humans to the moon by 2024 as a stepping stone for Mars. SpaceX's Starship, currently under development, is designed with the red planet in mind. It might sound like a far-off dream, but remember, so did walking on the moon once upon a time. Who knows, in the future we might call Mars our second home.